Assalamu alaikum students. Today we will study the first chapter of BMath. Today we will study first chapter of BMath102 course, which is mathematics for decision making. So in this course we will follow this book, Mathematics with Applications in Management and Economics, written by Pritchett and Saver. So today we will study mathematics with in this course we will follow Mathematics with Applications in Management and Economics, 7th edition, written by Pritchett and Saver. Right. So if you buy this book, if you follow this book, you need to go to problem set 7.5 of this book. So we will start our syllabus with differential calculus. Differential calculus is very important in business and economics. Not only in business and economics, it has wide application in almost all fields, including medicine, including biological science, engineering, and almost in all fields. It has wide application. Right. So suppose we have a function here. We have a function here. This is the symbol of function. This is the symbol of function. So the name of the function is f here. The name of the function is f here, where x is the variable. Right. So here the function is given as 2 plus k. Question is asking us to find out derivative of fx. So we need to find out derivative of fx. So when you find derivative of fx, it becomes f prime x. So if you see there is one prime there, if you see there is only one prime there, that means you need to do differentiation for only one time. So that means if there is a one prime or one stroke is there, that means you need to, if there is a only one prime there, that means you need to do differentiation for only one time. Right. So then again this is the differentiation sign. This is the differentiation. Some people write differentiation sign as like this way, and some people write it like this way. So it's the same. So d by dx means differentiation. So we need to do differentiation of, so f prime x means we need to do differentiation of fx. We need to do differentiation of fx. So differentiation of fx, that means fx means we have fx means function of x is twice 2 plus k. That means we need to do differentiation of 2 plus k. Right. So when you get something like this, so what do you have to do? You have to separate each part. If there is a plus or minus inside the function, what do you have to do? You have to separate each part. That means you need to do differentiation of each part separately. So you can do differentiation of 2 first, and then you can do differentiation of k. And remember, when the rule of differentiation dictates that if there is no variable, so here again see here, this is the variable, so this is the variable. So if you want to do differentiation, you must have a variable inside the bracket. That means you must have a variable. That means if you can only do differentiation of a variable. Since there is no variable in here, differentiation of this one is 0. This one is like a constant because it doesn't have any variable. Here only 2 is there. That means it doesn't have any variable. That means it will be considered as constant. and differentiation of a constant is 0. So this one will be 0. This one is again we do not have any variable there, because here variable is x. Here variable is x. That means we need to do differentiation. We need to do differentiation of these one. We need to do differentiation of these one with respect to x. That means we need to do differentiation of these one with respect to x. X is the variable. Since we do not have any variable here, this will be considered as constant. That means if you do differentiation of these one, we get 0, which is equals to 0. Right. Let's move to next one then. Question number 2. Here the variable is x, and the function of x is x. The function of x is x here, right? So you need to do derivative of x, fx. That means you need to do differentiation. You need to do differentiation of function of x, right? As I said before, when you do differentiation, the sign becomes f prime x, which is in other way you can write it like this way. d by dx of function of x. That means differentiation of function of x. You can write it like this way. You can also write it like f prime x, right? So here function of x is only x. Here function of x is only x. So here the variable is x, and we have only x there. So which means the answer will be 1. The answer will be 1. Right. So but suppose if you want to, so that means, remember, when you want to do differentiation of x only with respect to x, the answer is 1. This is the formula. But suppose the function is 3x here. Suppose the function is 3x here. So in that case, you need to do differentiation of 3x. In that case, if you get something like that, what you have to do, you need to bring 3 outside. You need to bring 3 outside. So that means, I'm saying again, if you want to do differentiation of 3x with respect to x, in that case you should only, this 3 is in multiplication with x. This 3 is in multiplication with x. So that's why you need to bring 3 outside. In other way, this 3 is called coefficient of x. This 3 is in multiplication with x, which means this 3 is the coefficient of x here. So you need to bring these 3's, outside. So we need to bring these 3 outside of d by dx, right? So like this way, and then 3 multiplied by 1, because as I said before in the last problem, if you want to do differentiation of x with respect to x, you get 1. So that means the answer is 3 multiplied by 1, which is 3, which is only 3. Similarly, if there is 18x there, so that means if you have 18x here, that means if you want to do differentiation of 18x, if you want to do differentiation of 18x, so I'm saying again, if you want to do differentiation of 18x, in that case here this 18 is in multiplication with x, so that means this 18 is the coefficient of x. So you need to bring this 18 outside. You need to bring this 18 outside. You need to bring this 18 outside because this is the coefficient of x. So you need to bring this 18 is in multiplication with x. So you need to bring this 18 outside. So that means we will have 18, and as I said before, differentiation of x with respect to x, differentiation of x with respect to x is only 1, so 18 multiplied by 1, 18 multiplied by 1, we have only 18 there. We have only 18 there, right? Now suppose the function is now 18x plus 12. Suppose the function is now 18x plus 12. So function is now 18x plus 12. So that means we need to do differentiation of this function. So that means we need to do differentiation of 18x plus 12. So similarly, what do you have to do now? So you have to separate each part. As I said before, there is a plus inside the function. So there is a plus inside the function. So what do you have to do? You need to separate each part. So you need to separate each part. So it will be like this. That means you need to do differentiation of 18x first, and there will be a plus in between, and then you need to do differentiation of 12. So like this way, you need to do differentiation of 18x first, there will be a plus in between, there will be a plus in between because there was a plus in between here. So that means, and then you need to do differentiation of 12. So so these one first, we need to do differentiation of these one first. Sorry, so you need to do differentiation of these one first. So as I said before, this 18 is in multiplication with x, so that means this 18 is in multiplication with x. So you need to bring this 18 outside. You need to bring this 18 outside, and then this one. So this one, the answer, if you want to do differentiation of 12, if you want to do differentiation of 12 with respect to x, as I said before, since there is no x here, since there is no x here in front of d by dx, in front of this d by dx, here where the x is the variable, where x is the variable, in front of this d by dx, we do not have any x here. We do not have any x here. So if you want to do differentiation of this one, the answer is 0. Right. So now here we have only x, and you need to do differentiation of x with respect to x. So this is, the answer is 1. So that means 18 multiplied by 1, and this is the, and this is 0. So you do not have to write, this is 0, you do not have to write this one. So equals to 18. So if you can see, it doesn't matter what number you add here in the function. It doesn't matter what number you add here in the function. Maybe this is 225. So it doesn't matter what number you add here. The answer will still be same. Answer will still be same, because if you add 225 here, the answer will still be same. Because here there is no x. So that means if you want to do differentiation of this one with respect to x, in that case, since there is no x here, the answer will be 0. Answer will be 0. Answer will be 0. So that means the answer will, full answer will remain 18. It doesn't matter what constant number, it doesn't matter what number you put there. The answer of differentiation will only vary based on this one, not based on this one. Right. So similarly, if you put, instead of plus, if you put minus excuse me, instead of plus, if you put minus there, so in that case, here we will have a minus there, and here we will have a minus there. So that means it doesn't matter what you have in between. If you have plus or minus, in both case you need to separate each part. That means it doesn't matter whether you have a plus or minus in between. If you have a plus or minus in between, it doesn't matter whether you have a plus or minus in between. You have to separate each part. You have to separate each part. So here we will have a minus then. In that case, still you can see the answer is still same. Answer is still same answer, because the answer is still same answer, because here you do not have any variable, because here you do not have any x there. So that's why answer still remains same. Answer will only vary based on this one, based on this one. For example, if you put 2.25x, then only answer will vary, because now the number with the variable has changed. That means here if you put 2.25x, in that case here you will have 2.25. So in that case here you will have 2.25, because this 2.25 is the coefficient of x, because this 2.25 is in multiplication with x. So you need to bring this 2.25 outside of x, right? So similarly here we will have 2.25. So that means, as I said before, if you want to do differentiation of x with respect to x, in that case the answer is 1. So the answer is 2.25. 2.25. Right. Let us solve question number 3 then. What we have here, x by 2. The function is here x by 2. Right. So here the function is x by 2. That means you need to do differentiation of x by 2. Right. So x by 2 means like excuse me, x by 2 so you need to do differentiation of x by 2, which can be written as like x by 2. So this can be written as x by 2. Right. So then again, as I said before, you need to separate. When you get something like this, you need to separate x. So you need to separate x. When you get something like this, you need to separate x from the number. Right. So here I have separated x from the number. Since we do not have anything here, we will put a 1 there. So this way we can separate x from the number. And then as I said before, this half is in multiplication with x. So that means this half is coefficient of x. This half is coefficient of x. So this one you need to bring this one outside. You need to bring this one outside. So now we have half outside. It will be there as it is. And differentiation of x with respect to x is 1. So differentiation of x with respect to x is 1. The answer is 1. So if you multiply 1 with half, we get only half. So this is the answer. Now for example, instead of 2 here, we have 7.5. Suppose if we have 7.5 here, that means if we have 7.5 here, in that case here we will have 7.5, here we will have 7.5. So that means we have separated the number from the variable. So we have separated number from the variable x. So we will have 7.5 here. So as I said before, differentiation of x with respect to x is always 1. Right. Excuse me. So we will have 7.5. So that means the answer will be here 7.5. 1 by 7.5. This will be the answer. Right. So now suppose the variable is changed. Let's see. Now suppose the variable is p. Let's see, the variable is p now. So if the variable is p now, and let's see the function is x. function is x by 7.5, x by 7.5. In that case, what will be the answer of this? So please notice here first, the variable is, this is the variable here now, p is the variable, but we do not have any p here, so here p is the variable, but we do not have any p here. So that means you need to do differentiation with respect to p, so that means we need to do differentiation with respect to p. Excuse me. So you need to do differentiation with respect to p. So that means you need to do differentiation with respect to p. Here we will have p, but the function is x divided by 7.5, but the variable is p, right? In this case, see, as I said before, here the variable, this is the variable, so that means you need to do differentiation of this one with respect to this variable. So this variable must be there, that means this variable must be there in the function, otherwise answer will be 0. Because this one, since there is no variable here, the variable is no longer x, the variable is now p. Since we do not have any variable here, we do not have to do differentiation. The answer is 0. Right. So suppose the variable is y, and we have five by y minus 2y. This is the function. Suppose we have a function like this, where y is the variable, right? So if the function is like this, in that case, so here the variable is y, so that means variable is y, and the function is this one, right? So this is the function, where the variable is y, so that means you need to do differentiation with respect to y, right? So in that case, as I said before, our first task is to separate each part. There is a minus here. As I said before, if there is a minus or plus, in that case you need to separate each part. So we will separate each part first. So we have separated each part. 5 by y is the first part, 5 by y is the first part, and then in between we have a minus, in between, and then we will the second part, and then the second part, right? Okay, so right, so as I said before, you need to separate each part first. You need to separate each part first, right? So that means, sorry, and then that means now what we have to do, we have to, as I said before, we need to, if you want to do differentiation of these one, you need to separate these number, from here, right? You need to separate the number from the variable. So you can bring these 5 like this way, and since we do not have anything here, we will put 1 there. So again, as I said before, you need to separate these 2 from the variable, because this 2 is the coefficient of y. So you need to bring these one outside, right? So now what we will do, so as I said before, you need to bring these one. This 5 is in multiplication with this one, so that means this 5 is the coefficient. So you need to bring this one outside. And this one, differentiation of y with respect to y will always be 0. So here y is the variable, and here y is the variable, and here we have only one y. That's why the answer, differentiation of these one with respect to y will be 1, right? So now here, whenever you see the variable is in the denominator, in that case, you need to bring these one up. That means the variable cannot be in the denominator. You need to bring these one up to process it, to do the differentiation. So to do the differentiation, you need to bring the variable up from the denominator. So how we do that? Always remember, here we do not have any power. Here, but here there is no power here, but there is actually a power here. What is that power? That power is 1. We do not have any power. Actually there is a power which is 1, because power 1 you do not need to write it. Power 1 doesn't mean anything, doesn't make any change in the number. So that's why here we do not have any power. So in other way, there is a power which is 1, and 2 multiplied by, and this here 2 multiplied by 1, we will have only 2 here, right? So here we have like this. So now what we do? So you need to, as I said before, you need to bring these variable from the denominator to numerator. That means you need to do the differentiation. The variable cannot be in the denominator. To do the differentiation, you need to bring these one to numerator. You need to bring these one excuse me. So you need to do the differentiation, you need to bring the variable from the denominator to numerator, or you need to bring the variable from the denominator to up. You need to bring these one up, right? So how we do that? So when you bring a variable from the denominator to numerator, or when you want to bring it up, what will happen is the power it has, the power become negative. That means if you want to bring these one up, what we'll have is this one will become, the power will become negative. The power will become negative. So if you want to bring this one up, the power will become negative, right? So I'm saying again, if you want to do the differentiation of this one, what do you have to do? You have to bring these one up first. So when you bring these one up, the variable, the exponent with the variable, that means the power with the variable, will become negative. If you want to bring these one from the denominator to numerator, or if you want to bring these one up, the power will become negative. So power will become negative. So to do the differentiation, you need to bring this one up, right? So now we have a new formula. We'll study a new formula. So when you do differentiation of a power, when you do differentiation of a variable with a power, there is a power here. So there is a power here. When you do differentiation of a variable with a power, always remember the answer will be like this: power. We need to bring the power will come down. That means power will come first. That means this power, you need to bring these one first. That means this power will come down, and this power you need to write this power first, and then power will be deducted by 1. Power will be deducted by 1. Power will be deducted by 1. I'm saying again, this is a new formula. So when you do differentiation of a variable, this is the y is the variable here, and when you do differentiation of a variable along with power, when you want to do differentiation of a variable along with power, what will happen is the power, whatever you have in the power, you need to bring that power first, right? That you need to write that power first, and then the power, we had only -1 there, and from that power, doesn't matter what you have in the power, from that power you need to deduct 1. From that power you need to deduct 1, right? So what we have now, so here this minus will come first. 5 into 1, this 5, 1 into 5 will be, we will have 5. So minus 5, and then here what we get, here we get minus 2, because here minus 1, that means we get minus 2, we get minus 2, that means we get minus 2, power minus 2, and here we had minus 2 before, right? So you can keep it like this way. This is the answer. But in the question it said find f prime x. That means you need to do differentiation. F prime x means differentiation. So you need to do differentiation, but do not leave negative exponent in answer. That means after you solve all problem, you cannot leave negative power. Exponent means power. You cannot leave negative power in your answer. So that means here we got a negative power in the answer. So that means negative power cannot be there. So negative power cannot be there in the answer. So we need to process it further. Right. Minus 5, and then always remember, if you want to remove the minus from the power, what you have to do, you have to get a fraction first. You have to get a fraction. If you want to remove the minus from the power, you have to get a fraction first, and then you can take that variable along with the power in the denominator, except the minus sign. That means if you want to remove the minus from the power, what you have to do, you need to move the variable along with the power in the denominator, except the power. So when you move it to the denominator, the minus from the power will no longer be there, and since we do not have anything there, we can put a 1 there, minus, and then we had a minus 2 there, we will put it there. Right, so we can simplify a little. That means that's the beautification of the problem. So here 5 multiplied by 1 multiplied by here 5 and multiplied by 1, 5 multiplied by 1, we can write 5 there. So that's the answer. Right. Okay. Now suppose let us solve another problem. Right. So now, for example, we have a function like, for example, 2.75 x, no, not x. Here the variable is y. So suppose we have a function like y power 6.5. Right. So suppose we have a problem like this, we have a function like this. Excuse me. So we need to do differentiation of this function. So which means here the function is this one, right. So here the function is this one. The function is this one, where the variable is y, so this is the variable, so we need to do differentiation of the function with respect to y. So we need to do differentiation of the function with respect to y, and the function is 2.75 multiplied by y to the power 6.5. Right. So as I said before, you need to separate this one from the variable. This is the variable with power. So here you need to separate this one from the variable. This is the coefficient. This is the coefficient of y, because this is in multiplication with y. So you need to bring this one outside. You need to bring this one outside. Right, you need to bring this one outside like this way, and then so you need to bring this one outside, and then we will solve it like this way. So now we need to do differentiation of this one. As I said before, so whenever you see there is a power over a variable, this is the variable here, this is the variable, and we have a power over a variable. So whenever you see there is a power over a variable, that power need to come down. You need to write the power first, right? So if you do differentiation, you need to write it like 6.5. that means it will be like this. So that means the power, this power, you need to write the power first. To do the differentiation, you need to bring the power first, and then the existing power. From the existing power, you need to deduct 1. So from the existing power, you need to deduct 1 from the existing power. The existing power was 6.5, and from that you need to deduct 1. Right. So I'm saying again, to do the differentiation of a variable with the power, whenever you see there is a variable whenever you see there is a power over a variable, and if you want to do differentiation, in that case you need to bring the power first. And then the power will be deducted by 1. That means from the power you need to deduct 1. Right. So now this one should be multiplied with this one. So 2.75 multiplied by 6.5. Let's open the calculator. .75 multiplied by 6.5. So 2.75 multiplied by 6.5 is 17.875. Right. And then we have what? This one, y to the power 6.5 minus 1. So that means if you deduct 1 from 6.5, we get only 5.5. So that's the answer. So this is the answer. Right. Now. Now suppose the function is like this now. Suppose the function is like this. So whenever you see a function like this, how we do it? Right. Right. So here the function is like this one. Okay, so that means we need to do differentiation of this one. So we need to do, this is the function now. This is the function now. So that means we need to do differentiation of this one. Right. So we have solved one problem like this before. So whenever you get something like that, you need to separate this number from the variable. You need to bring this one out. So that means you need to separate this number from the variable. Excuse me. So since we do not have anything there, we will put a 1 there. Right. So this 2.75 is in multiplication. This 2.75 is in multiplication with the variable. So that means this 2.75 is the coefficient. So it has to come out. It has to come out. Right. So this is today is the beginning lecture of differential calculus. That's why I am showing very slowly so that you understand the full part. But after a few class, I will go first. After a few class, I will not show simple breakdowns. I'll go first. Since this is the first class of differential calculus, that's why I'm showing you each breakdowns. Right. So now we need to do differentiation of these one. So as I said before, here whenever you see that the variable is in the denominator, to do differentiation, you need to bring these one up. So to do difference, whenever you see the variable is in the denominator, to do differentiation, you need to bring these one up. So how we do this? When you bring these one up, the exponent or the power with the variable will become negative. So that means when you bring these one, when you bring the variable from the numerator to when you want to bring this variable from the denominator to numerator, that means when you want to bring this one up, the power with the variable will become negative. So power will become negative. So that means I'm saying again, to do the differentiation, you need to bring the variable from the denominator to numerator. That means you need to bring the variable up, and to bring the variable up, what you have to do is you have to put a negative sign in the power. You have to put a negative sign in the power. You have to put a negative sign in the power, right? So now to do the differentiation, when you do the differentiation of a power, that power should come first. That means that power will come first, like this way. Oh, sorry. That power will come first like this. So when you want to do differentiation of a power, that means when you want to do differentiation of a variable along with the power, in that case that power will come first. That power will come first, and then from the existing power you need to deduct 1. From the existing power you need to deduct 1. Right. So now here this minus 6.5 is in multiplication with 2.75. So minus a plus a minus. So we need to put the minus first, and then 2.75 multiplied by 6.5. 2.75 multiplied by 6.5. Right. See, here is there. We have done the multiplication before. 2.75 multiplied by 6.5 is equal to 17.875. So we have 17.875. 17.875. Yes. And then what we have here? So in the power we have minus 6.5 minus 1. So that means we will have minus 7.5. Excuse me. So differentiation is done. Differentiation is done. But the question said do not leave negative exponent in answer. That means after you solve the differentiation, you cannot leave negative exponent, that means negative power, in the answer. So that means we are not done yet. Here the power is negative. That means in the answer negative power cannot be there. So what we do it? So to remove the negative power, so to remove the negative power, so to remove the minus from the power, what do you have to do? You have to put this one there without the minus sign. So let me say, that means I'm repeating again. When you had to bring these one, remember when we wanted to bring these one up, we had to put a minus sign. When we wanted to bring these one up, we put a when we wanted to bring these one up, we put a negative sign with it. Now we want to remove the minus sign from the power. When we want to remove the minus sign from the power, so that means we will move it back to denominator. To remove the minus sign from the power. We will move it back to denominator. Since we do not have anything there, we can put a 1 there, right? So now minus will be there, and these one multiplied by 1 means we will have this one, right? So that's the answer. That's the answer. Okay. So let's check out some very easy problems now. So here the function is x by 3 plus 4. So that means we have differentiation of x by 3 plus 4. As I said before, there is a plus in between. Whenever you see a plus or minus in between the function, in that case you have to separate each part. So x by 3 and then plus 4. Right, so you have to separate, and then again, as I said before, you have to let me do one more step here so that you get a clearer picture. So you need to bring the x out from here. You need to bring the x out from the number. So you have to put it like this way. So like this way. So that means to do the differentiation of x by 3, you need to move the coefficient out. So that means you should have only variable. So numbers should be kept out. So that means we will put it like this way. Since we do not have anything there, we'll put a 1 there. Okay. And differentiation of these one. See here no variable is there. So it is a constant. And the differentiation of a constant is 0. And differentiation of a constant is 0, right? So 1 by 3 is in multiplication with x. 1 by 3 is in multiplication with x. So that means you need to move these one out. So we are left with only x, differentiation of x. So differentiation of x with respect to x is 1. So 1 by 3 multiplied by 1. So we have only 1 by 3. So that's the answer. Okay. Now let's check out this one. First of all, let me see how long we have done. Yes, it's we have almost 45 minutes left to go for. Right. So now the function is like this. So that means 2 by 3 minus 3 multiplied by x divided by 2. So that means we have 2 by 3 minus 3x by 2. So we need to do differentiation of this one. So here there is a minus inside the function. So as I said before, if you see a plus or minus inside a function, so you need to separate each of the part. So first part is 2 by 3, and if you notice, there is no variable here. So obviously if you do differentiation, answer will be 0. And the second part is 3x by 2. 3x by 2. Second part is 3x by 2. So that means it's like if I write it in other way, 3x by 2. Let me write it like this way so that you get a clearer picture. 3x by 2. So we have to do the differentiation of 3x by 2. Differentiation of 3x by 2. So 3x by 2 can be written as like this. So what we have to do is, as I said before, you have to move these x. That means this 3 by 2, this 3 by 2 is the coefficient of x. Coefficient of x, because this 3 by 2 is in multiplication with x. So you need to move this one out. So it has been done. So we have moved this one out. And so now 3 by 2 is in multiplication with x. So obviously this 3 by 2 coefficient, this 3 by 2 is coefficient, it has to come out. So like that way, right? And obviously 0, you can just omit it, you can just leave it out. So we are left with minus 3 by 2 differentiation of x with respect to x. And as you know that, so this one is already out. So we are left with only x. We are left with only x. So we are left with only x. So you know that differentiation of x, we have only one x there. So the differentiation of x with respect to x is 1. The answer is here 1. So that means we are left with minus -3 by 2. Right, that's the answer. This one is a very easy problem. We have 3x square plus twice x minus 5. This is the function, and you can see there is a plus, there is a minus. So you need to separate each part. So first part is 3x square, second part is twice x, and third part is 5. So as I said before, this 3 is in multiplication with the variable. So this 3 is coefficient. It has to come out. So we have only x square. That means we need to do differentiation of x square. And similarly, here 2 is in multiplication with x with the variable. So these 2 need to come out. So, and then again this one, it doesn't have any variable, so it's a constant, and differentiation of a constant is 0. So differentiation of a constant is 0. Now see, so 3 is outside. Now the variable has a power. As I said before, whenever you see a power with the variable, and if you want to do differentiation, that power should come first. And then you need to deduct the power by 1. See, the power was 2, and from that 2 we deduct 1. So we deduct 1. So that means we have, and here this one, here we have only 1x. So we are doing differentiation of x with respect to x. That means the answer is 1. So 2 multiplied by 1 is 2. And here we have 3 multiplied by 2. 3 multiplied by 2 is equal to 6. And here we have x to the power 1. We have x to the power, here we have x to the power 1, and you know that the power 1 need not to, you don't need to write, you can just leave it. Whenever you the power 1 is 2 minus 1, the power 2 minus 1 is equal to 1. So power 1, you don't have to write it, so we can just leave it like that. We can just leave it like this. So 6x plus 2 is the answer. Right, so now this one, we need to do differentiation of this one now. X cube divided by 3 minus x square divided by 2 plus x plus 12. So here, as you can see, there is minus, there is plus there. So that means you need to separate. Here we have 4 parts, this one, this one, this one, and this one. So each part needs to be separated. Each part needs to be separated. So that means you can see each part has been separated. The first part is x cubed by 3, second part is x square by 2, and like that way. All the parts are separated. In between we had minus, we had plus, and like that way. So now, so here we had minus, so here we also have minus. Here we have plus, so here we have plus, and like that way. So here, as I said before, let me do one more step here so that you get a clearer picture. So as I said before, this x needs to be filtered out. This x needs to be separated. This x, the variable x, needs to be separated from the numbers. The variable to do differentiation, you need to move these one. You need to move the variable from the number, from this number. So we have moved these one. We have moved these one to right hand side. So since we do not have anything there, we can put a 1 there. Similarly here also we need to keep this one out. We need to separate it. So since we do not have anything there, we can keep it like that. We can put a 1 there. So like that way. And this one we can do it. So here we have only x. So that means we have only x there, and we are doing differentiation of x with respect to x. And here the answer will be, we can do the differentiation. The answer will be 1. Right. So here we have only 1x. That's why when you do differentiation, the answer is 1. Here we do not have any x, we do not have any variable. Here we do not have any variable. So that's why if you do differentiation, since we do not have any x is the variable. Since we do not have any x there, thus this is a constant. So the differentiation of a constant is 0. So 0, you don't need to write 0 here. You can just omit it, and you can see this 1/3, this 1/3 is in multiplication with the variable. So it has to come out. So inside the bracket we have only x to the power 3 is there for differentiation. Right. Similarly, this is the coefficient. We need to move it out, so we are left with only x square here. Right. So now, as you can see, there is a power over a variable. So there is a power over the variable. So to do differentiation, the power should come first. The power should come first, and then you need to deduct 1 from the existing power 3. From the existing power 3, you need to deduct 1. Right. Then here the power was 2. So the power 2 should come first. The power 2 should come first, and from the existing power 2, you need to deduct 1. You need to deduct 1. So what we have now, as you can see, 3 multiplied by 1 by 3. So these 3 and these 3 should cancel out. So these 3 should cancel out. So we are left with only x to the power 3 minus 1, which is 3 minus 1 is 2. So that means we are left with x square. And then again here these 2 multiplied by half, that means these 2 and these 2 should cancel each other out, and we are left with x to the power 2 minus 1. So 2 minus 1 is only 1. 2 minus 1 is only 1, x to the power 1. And you know that power 1 you don't need to write it. So the answer is x square minus x plus 1. Right. So we will end up here. Next class we will continue from question number 12. No, let us finish it. These are the problems we have already studied. We have already studied most of these problems. So all right, okay. So let me note, these are the things already I have discussed it. Question number 12, you study at home. Question number 20, study at home. Question number 22, you study at home. See here, question number 22. See here, variable is x. So that means you need to do differentiation of this one with respect to x, where x is the variable. Since we do not have any variable inside, the answer is 0. Right. So you solve question number 24 at home. You can do it at home, I know. So right. So from question number excuse me. So we will end up our discussion. We will end up our today's discussion up to page 19. So from page 20 we will study next class. So we will study in our next lecture. We will study from page 20. That means from question number 25. From question number 25 we will study in our next class. If you have any question, if you fail to understand any part of the lecture, please do not hesitate to ask me. Please do not hesitate to knock me. You can knock me over. You can ask your question. You can get help from me over your messenger group, over the Skype group, or also you can also call me. You can also email me. So please, if you do not understand any part of the lecture, please do not hesitate to get help from me. So that's the end of the lecture 1.